Assalamu alaikum. We know a vector which gives the position of an object is referred as position vector. In this video, we will discuss about the displacement vector in terms of position vector. For that, I consider an object whose position is a P1 at any given time. See, I consider an object who is at a point of P1 where the position vector is given as x1 I cap plus y1 j cap plus z1 k cap. This is the position vector of the object at point P1. Here, for convenience, I represent this one by letter R1 vector. This is the position vector of the object at point P1. Then after some time, if the object moves to point P2, then at point P2, the position vector of the object is taken as R2 vector, which is represented as x2 I cap y2 j cap plus z2 k cap. This is the representation of position vector using a coordinate system. It is then how do we represent the displacement vector? Let me show this to you. Here, displacement vector is represented by letter delta R vector. And it can be obtained if you subtract these two. If you subtract R1 vector from R2 vector, you will obtain delta R vector. Okay. Now we know the value of R2 vector. Now this I am going to substitute here. x2 I cap plus y2 j cap plus z2 k cap. It is subtracted from the value of R1 vector, which is nothing but x1 I cap plus y1 j cap plus z1 k cap. Now if you look at this term, you may find that it has got certain values with the same unit vector. Here I cap is present, here also I cap is present. In the similar way, these two terms have same unit vector, and these two terms have got the similar unit vector. I take such terms and write them separately. Currently speaking, I am going to simplify this equation. See, x2 minus x1. Yeah, I cap. If you want, let's increase one more step so that it becomes easy for you to understand. Okay, I take these two terms, x2 I cap, then here minus x1 I cap plus y2 j cap, here minus into plus is minus y1 j cap plus z2 k cap minus multiply with pluses minus z1 k cap. Okay, this is what we get. Now I will take out the similar terms. Delta R vector, which represents displacement vector, is equal to x2 minus x1. What is the common term here? I cap, so it's taken out, plus y2 minus y1. The common term is j cap, is taken out, plus Z2 minus Z1 multiplied with a k cap. So this is how we write this equation. Clear? And now what is obtained here is nothing but the displacement vector, okay, of an object when it moves from position P1 to position P2. Okay. Now let me show this to you with the help of a simple diagram. Now suppose this is the coordinate system. This represents the x-axis, this represents the y-axis. Then position P, I take this as position P1, and this represents the position vector R1 vector. Okay, then I take another position, that is P2. Here this line which connects to the origin gives us the position vector of the object located at point P2. It is R, it is a vector R2 vector. Okay. Now how to get or how to represent the displacement vector? Let me show this to you. You see here I connect the point of P1 and P2 with the help of a line with the arrow mark. See, these two are connected. This line which I have obtained by connecting P1 and P2 gives me delta R vector. Now, and it represents a displacement vector. Okay, is equal to R2 vector minus R1 vector. This represents R2 vector minus R1 vector. Clear? This is how one can represent a displacement vector using a graph. Okay. Now I'll solve one problem, a numerical problem relevant to this. The question is 2.17. Calculate the displacement vector for an object which moves from point P to point Q. Okay, let me do it here. This question is provided with a graph or a diagram in which this is taken as a point P. What is this? This is given as point P. Okay. Then this is the position of the object at any given time. Then it moves to a new position. This is the given letter Q. This is the new position of the object. Okay. And a graph, this point represents 1. Here along the y-axis, this is the first point. Second, third, fourth. Right. This is the position of a Q. 1, 2, 3, this is 4, 1, this is 2. Okay. Now let me show you how to get the displacement vector here. Here this line represents a position vector shown by letter R1 vector, and this gives me the position vector, the position of the object at a given time. Okay, so to get the displacement vector, what has to be done? We connect these 2 points, the help of a line. Okay, this line gives me the displacement vector and represent letter delta R vector. We know delta R vector is equal to R2 vector minus R1 vector. Okay, so here let's find out the value of R1 vector and R2 vector. Okay, here R1 vector. What is the value of R1 vector? See, this is x-axis, this is y-axis. This point have its position along x-axis at 1. So 1, and the unit vector which acts along x-axis is I. So 1 I cap, and the position of R1 along y-axis is nothing but 1, and as we know, the unit vector which acts along y-axis is nothing but j cap. So, and we know very well, if we write 1, it is not necessary to mention that. It can be represented as I cap plus j cap in a simple way. Now next, see R2 cap, R2 vector, I am sorry. Now let me write the value of R2 vector with the help of this graph. Here, if I drop a line from point Q, it intersects at point 4 along the x-axis. Now if I do the same thing from here, then it intersects at point 2 along the y-axis. This gives the position of Q at any given time. So what is the position? Here along x-axis it is 4. The unit vector along x-axis is nothing but I cap, and the position of Q along y-axis is 2, and the unit vector along y-axis is j cap. Fine. So this is R2 cap. Now from this I am going to get a delta R vector, which is going to give me the displacement vector, delta R vector. So see, in the place of R2 vector I am going to write its value. What is that? For I cap plus 2j cap minus I cap plus j cap. Now see, for I cap minus I cap here plus 2j cap minus multiplied with pluses minus j cap. Now I am going to simplify this. Here, if there is nothing beside I, means it is equivalent to 1. Okay. So I is taken out in common. Similarly, here I take out j as common, j cap. This give me the displacement vector, delta R vector. Okay. So here delta R vector is equal to 3I cap plus Here 2 minus 1 is 1. J cap. This is the position vector of the given object. Right? Now, how to get the magnitude of the displacement vector? So I said this one has a position vector. This is not position vector. This is the displacement vector. Here, how to get the magnitude of this displacement vector? Let me show this to you. The magnitude of a displacement vector. So delta R vector. Now can be obtained very easily. Here, as I am going to represent the displacement vector. So we have to the magnitude of displacement vector. So we have to write the symbol for vector, because this represents only the magnitude. So here I take a root of, the square root. I write first I take this, I square it, plus I square this. Okay, let's see what I get. On squaring 3 I get 9, on squaring 1 I get 1. So 9 plus 1 is 10. So delta R value, the magnitude of a displacement vector is nothing but root 10. So this is how one can easily obtain the displacement vector of a given object, and with the help of that its magnitude can be obtained by following this method. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.